Lesson 4.8 is functions and relations. So what this has to do with is, if you remember all the way back in chapter 1, we talked about functions. And for an equation to be a function, for every input, there has to be exactly only one output, okay? So open up in your books to page 256, and I'm going to write on this slide kind of what page 256 says, and this will be sort of our example 1. So first of all, what they have in the book is they have a chart that looks like this. They have input, and they have output, okay, and they have the numbers 1, 2, let me make this a little bit smaller. 1, 2, 3, and 4. And then in output, they have 2, 4, and 5. And they have arrows drawn to it. For the input of 1, we have an output of 2. For the input of 2, we have an output of 4. For the input of 3, we have an output of 4. And for 4, we have an output of 5. So, would this represent a function? So, you got to make sure for every input there's only one output. So how many arrows does number 1 have drawn from it? 1. Okay, then I know that's right. 2, how many arrows? 1. 3, 1, 4, 1. So I know that yes, this chart would represent a function. So yes, it's a function. Now, let's look at the next one that it has in your book, and it has 1, 2, 3, and 4. I'm going to erase the arrows. And then the numbers in the output are 5, 7, and 9. So it tells me for the input of 1, I have an output of 5, and it has another arrow being drawn to 7. That should be your red flag right there. For the input of 1, how many different outputs does it have? 2, because it has a 5 and a 7. Then I can just look at the rest of the chart basically and see that this is not going to be a function because of this right here. For the input of 1, I have 2 different outputs, okay? Again, that's review from chapter 1. Now, also on page 256, if you look down, we're going to be looking at functions in relations to lines and equations. So remember what we've been doing, y equals mx plus b form. We can graph an equation as a line. So what they're saying is I can have a graph, okay? This is my y-axis, this is my x-axis. And I can have a line on that graph and I will know, is this a function? So let's say I have a line that looks like this, okay? We have something called a vertical line test. If I can draw a line through my graph at any point, a vertical line, and it only hits the line that's been graphed one time, then I know it's a function. Look, it intersects it here, but it doesn't intersect it anywhere else. It intersects it here, here, and here. So every time I draw a vertical line, it only intersects my graph one time. So that would be my vertical line test, okay? So let's try it again, but with another graph, okay? Let's say that our graph looked like this. All right, again, let's try our vertical line. I'm going to draw a solid one now. How many places does it intersect? 1, okay. How many places does it intersect? 1. So I know that this also represents a function. But what if my graph were to look like this? Okay, let's do our vertical line test. Let's draw a line through it. How many places does this vertical line intersect with my graph? 2. So when it has when it intersects twice, then it is not a function, so no. Or if my graph were to look like this, okay, how many places is it going to intersect? 3 times, 1, 2, and 3. So I know that is not a function either. Okay, so that's how I can look at a graph and do the vertical line test and find out, will it be a function? Okay, so what does all this mean? What they want us to do is they want us to evaluate the function. First of all, function form or function notation is read, it looks like this right here, f of x, okay, and it's read f of x. That's what f the parentheses x is read, f of x, okay? And that's function form. And for whatever reason, for function form, obviously the f makes sense because it's function form. But for function form, for whatever reason, f, g, and h are all used in function notation. So I can have one that looks like this, f of x. I could have one that looks like this, g of x. And I could have one that looks like this, h of x. Those all represent function notation. Just because a letter is different doesn't mean you do anything different. It's all function notation. And what that does, okay, is basically they're saying it replaces the y in my equation. So at any time, I could take this f of x out and rewrite this equation y equals 7 minus 3x, okay? That's all that they're doing there. That's all that function notation means, is I know that at any time for the input of x, my output or my function is going to be y. So f of x. So what they want me to do is they want me to solve this function for the given value of the variable. So let's look at this problem and let's see. Let's plug in, and I forgot to write this down on the slide, but for this problem we're going to say x is equal to 4, and this one we're going to say x is equal to negative 2. Okay, so what you want to do is you want to plug in this 4 everywhere you see an x. That means up here and here. Now, what that tells me is for the input of 4, that's what that function notation means. When I input 4, I'm going to get this. Okay? Now, you're never trying to get f by itself. You're never trying to solve for x. You just want to solve and say, okay, for the input of 4, what did I get? So I do 7, then negative 3 times 4 is negative 12. And for the input of 4, remember this stays the same all the way through, I have an output of negative 5. That's how you do function notation. You solve the problem and you leave it in function notation. For the input of 4, I get an output of negative 5. All right, so let's do the next one. G of x, exact same thing, it's just used as a different letter. And I'm plugging in negative 2 for x. So I do 10 times negative 2 plus 3. Okay, again, g of negative 2 does not change. That tells me for the input of negative 2, what's my output going to be? 10 times negative 2 is negative 20 plus 3. And I get g of negative 2 is equal to negative 17. So basically, like I said, all this is telling me is for the input of negative 2 in the equation, the original equation here, I was able to get 17 as my answer. That's all that function notation is. So it's not anything challenging. It's just a different way to write an equation. So you have to remember, f of x, g of x, and h of x all mean the same thing. So it can be written, all of them can be written just like this, and those are all considered function notation. Also, another thing is all of these can always be replaced with y. Okay, and we'll see why that's important in this next example. This next example, they want me to graph the function. So what I need to do is I need to make sure my equation is in y equals mx plus b, or slope-intercept. We say, well, I don't see a y. What do I know I can replace f of x with? A y. So I do y equals 5x minus 4. Is this in slope-intercept form? mx plus b? Yes, it sure is. Okay, so let's find our slope, which is going to be m equals 5 over 1. We're going to write it in slope-intercept form, slope form, so rise over run. And my y-intercept is going to be negative 4. Okay, so let's graph this equation. Oops. Alright, x and y. And then I'm going to go down to the negative 4 and put my first point, because that's my y-intercept. And then I'm going to go up 5 and over 1. And I'm going to draw my line that goes directly, draw my line that goes directly through the 2 points, okay? And that's how you would graph an equation in function notation. All you got to do is replace the f of x with y, and then make sure it's in y equals mx plus b form to graph. And that's how we would do function notation.